Hey girls, so on Monday we're going to do a few more things with the arcane diagram. The first thing we're going to think about is what happens when you multiply by I geometrically. So I'm hoping that over the weekend you were able to prove that Z1, Z2 equals R1, R2 cis theta 1 plus theta 2. Which basically means that if I take any two complex numbers, so that's Z1 and that's Z2, then you take the two angles that they make, so we take this one and this one, and we add them together, which will probably take me to about here, and then the point Z1, Z2 has to lie somewhere in that line, and the distance is R1 times R2. So let's just say that's there, for example. So I can use that to geometrically find the position of Z1 times Z2, which is actually very useful for a number of things. So what happens if Z1 is I? So what happens if it's I times Z1? Or Z2, it doesn't matter. So there's I, and I'm hoping that you can see that for I, R equals 1 and theta equals pi on 2 or 90 degrees. So if I multiply Z1 by I, then I get R1, which is the modulus of Z1, times cis theta plus pi on 2. So if I have some point for Z1, which might be here, somewhere in the first quadrant, turns out that Z2 is exactly, IZ1 is exactly there, where it's an isosceles triangle, an isosceles right angle triangle, even more so, with the right angle at the origin there. It's a really important fact, and hopefully you can see as well that if I multiply by I squared, then I do exactly the same thing, but I add 2 pi onto or pi, and so I get that point there, where that's a straight line. And if I multiply by I cubed, I'll end up there, which is also the same as multiplying by minus I, because minus I is equal to I cubed. So that's phase 1 of what we're going to do. Phase 2 of what we're going to do uses this in a slightly different way. I'm just going to go to a new slide. So phase 2 says if Z equals R cis theta, then Z to the power of n equals R to the power of n times cis n theta. We won't prove it properly, but I'll kind of prove it argumentatively, I guess, where I'll kind of explain the argument, but it relies on induction, which is the next topic in extension 1. So I will prove it for you, but just not on Monday lunchtime, probably in a couple of weeks. And then we're going to use that to do a bunch of things, like we're going to we're able to do something like this. Oh, sorry, that's 1 plus root 3i to the power of 10 quite quickly. Obviously, I need to do a little bit more work than it would just be to write it down, but it equals 2 cis, so what's that, root 3 is the vertical, so it's 60 degrees or pi on 3, and hopefully you can pause the video at that point and confirm this just by plotting it on a number, arcane diagram, something like that. So that would be 2 to the power of 10 times cis 10 pi on 3. And then I could remove 360 degrees or 2 pi to give me 4 pi on 3. And then I could think about which quadrant that was in, and so it would be down here. And I could do all the things that I would need to do, multiply by 2 to the power of 10 to work that out quite quickly, instead of multiplying a bracket by itself 10 times, which would take you far too long to be useful. That's actually called, are you ready for this? It's got a really fancy name. De Moivre's theorem. the classroom next door actually just laughed at me, but I don't think they were laughing at me. The Moivre's theorem, and is going to be one of probably the biggest thing in complex numbers for us, I would think, is that one. So we'll do a bunch of arithmetic with that, and then what's going to happen after that is we're going to do more geometry, but that will be Tuesday morning, I would think, and I'll hopefully make another video for that at some point on Monday. All right, thanks, girls. See you on Monday at lunchtime.